Hello everyone, welcome to my channel. Today I'm going to share with you the book, A Matter of Degrees. What temperature reveals about the past and future of our species, planet, and universe. This book explores the crucial role temperature has played in the history of science, biological evolution, geological changes and the origin of the universe. Have you ever wondered why the normal human body temperature is 37 degrees Celsius, 98.6 degrees Fahrenheit? Or how the Earth has cycled between ice ages and warm periods? Or even how all matter in the universe was forged in the high temperatures of the Big Bang? Today, let's uncover the mysteries behind this fascinating concept of temperature. First, let's look at the huge impact of temperature on the development of science and civilization. The first key invention for science was the thermometer. The first thermometer was invented around 1600 AD. Its invention allowed humans for the first time to quantify and measure temperature. Before that, people could only sense hot or cold through feeling, without a quantified concept of temperature. The invention of the thermometer opened the door for systematic scientific study of heat as a physical quantity. Later, through the study of heat, humans invented the steam engine, which directly led to the outbreak of the Industrial Revolution. Most of the mechanical devices we rely on today are built upon our understanding of thermodynamics. So in a way, the invention of the thermometer changed the fate of humankind. Additionally, the study of heat gave birth to a new field of science, thermodynamics. Together with classical mechanics and classical electromagnetism, it forms the three pillars of classical physics. It's fair to say that without the concept of temperature as a breakthrough, it would have been difficult for modern science to make such rapid progress. Entering the 20th century, physics saw another revolution: the emergence of quantum mechanics. In the quantum world, matter demonstrates very peculiar behaviors at ultra-low temperatures around absolute zero. The various quantum effects we witness today, such as superconductivity and superfluidity, are all built upon precise control of extremely low temperatures. It is foreseeable that future technological advances will continue to be closely related to humanity's in-depth research and application of temperature. Next, let's change perspective and look at the role of temperature in the evolution of life. First of all, why do humans and other warm-blooded animals maintain body temperatures in a similar range? And how did this temperature range form? One hypothesis is that warm-blooded animals evolved to maintain constant body temperature in order to provide a stable working environment for their brains. Our brains are complex information processing systems, and the neurons inside require complex chemical reactions at suitable temperatures. If body temperature fluctuates constantly, it would be very difficult for the brain to function properly. So, in order to maximize intelligence, animals evolved the ability to precisely regulate body temperature. But why do the body temperatures of most mammals concentrate around 37 degrees Celsius? This is likely the result of long-term evolution and optimized balance point after weighing many factors. Higher body temperatures benefit metabolism efficiency and immune function, but also consume more energy. Excessively low temperatures would dampen vitality. 37 degrees Celsius is possibly the equilibrium settled upon through this trade-off. Of course, there are still many mysteries surrounding life's temperature regulation abilities. For instance, the exact mechanisms behind human fever are still unknown. We only know that fever enhances immune function, but the specific regulatory principles await further research. It's foreseeable that temperature will continue to be an important topic in the biological sciences. Zooming out further, we see that temperature determined the very survival of life on Earth. There have been many mass extinction events in Earth's history, nearly all caused by climate change. For example, the snowball Earth, that formed 700 million years ago, caused a massive die-off of species due to the cold climate, but this extinction paved the way for the later Cambrian explosion of life. As another example, the asteroid impact 65 million years ago threw up dust that blocked sunlight and lowered temperatures, eventually leading to the extinction of dinosaurs. Interestingly, after each mass extinction event, the surviving species would thrive and diversify. Mammals blossomed after the dinosaurs went extinct, eventually evolving into humans. So it's fair to say that adaptation to temperature has been a major driving force of evolution. Of course, we must also be vigilant about the effects of current global warming caused by greenhouse gases. The rising temperatures will have significant impacts on both marine and terrestrial ecosystems. This is a grave challenge facing humanity. Finally, let's broaden our horizon into the vast cosmos, and see how temperature influenced the evolution of the universe. According to the Big Bang theory, the earliest instant of the universe's existence saw temperatures as high as trillions of degrees Celsius. As the universe expanded, temperatures gradually dropped. Around 9 billion degrees, the first atomic nucleus, hydrogen, formed. In the hundreds of thousands of years that followed, temperatures continued falling, and electrons became bound to nuclei to form complete atoms, marking the birth of the material world. Essentially, every element in the universe was forged in the furnace of different temperatures. Hydrogen and helium formed in the searing heat following the Big Bang, while heavier elements up to iron were fused in the cores of stars. Higher core temperatures allow fusion up to heavier elements. The extreme temperatures in a supernova explosion can also produce elements heavier than iron. Therefore, everything around us has gone through the baptism of high temperatures, and all elements were brewed in furnaces at varying temperatures to arrive at their present forms. It's fair to say that temperature laid the foundations for cosmic evolution. Through today's explanations, we've discovered that this seemingly mundane concept of temperature has left its mark everywhere, spurring scientific advancement, driving biological evolution, reshaping Earth's history, and forging all matter in the universe. Temperature is like a hidden guardian of the world, silently witnessing every transformation, yet playing a unique role at each major juncture in history. I hope today's sharing has helped you glimpse the fascinating nature behind temperature. If you find this topic captivating, you can read the original book, A Matter of Degrees, for more comprehensive and in-depth explanations about the science. Thank you for watching. See you next time.